Okay, so vertex for a parabola. Um, so like I said, if we did completing the square, this will be a little more obvious where this came from. But what we know is that so I already showed you if I was in vertex form, it's really easy to go back to this standard form. If I'm already in standard form and I want to go to vertex form, I need to know what that vertex is. So if I'm already in this form, the vertex would be, you're going to take a negative b divided by 2a. Then after you do that, this is going to be the x-coordinate of your vertex. You're going to plug that back into your function to get that y-coordinate of your vertex. So really the only part of this that you're going to have to memorize is just this formula to use over and over again. Because like I said, once we get that x-coordinate, we just keep plugging it back in and we can get that coordinate. Okay, so for this function here, we're going to find the vertex, determine whether it's a minimum or a maximum value. And then, so we'll talk about how we do that. We'll talk about how we're going to find the range and on what interval is the function increasing and decreasing. Okay. What I'm going to do is I'm going to eliminate all of this right now. And the first thing we're going to do is we're going to find the vertex. So we know vertex is going to be negative b over 2a, and then the other part is just going to be f of negative b over 2a. The first thing we're going to do is we're going to find this part here. So just as a reminder, this is how we're identifying this. Because this x squared has a 1 on it, a is just going to be 1. B is that center part where the coefficient of just the x term, that's going to be 4. So we would have negative 4 over 2 times 1. So what we're going to get is negative 2. Okay. Now that we have this negative 2, like I said, this is the x-coordinate of my vertex. So what I'm going to do is I'm going to go back to this function here, and I'm just going to plug that negative 2 in. So we get negative 2 is going to equal negative 2 squared plus 4 times negative 2 minus 9. So we should have with a 4 minus 8 minus 9. Let me see, minus 4 minus 9, negative 13. So this part is because I plugged x in to get my y. That's the y coordinate. So we know now that the vertex is going to be at the point negative 2, negative 3. So if I want to rewrite my equation, fx can be rewritten as, so because a is the same as whatever a is here, let me write this out here first. Like I said, we already know that a is 1. This is h, this is k, so we're going to have x instead of minus 2 plus 2 squared minus 13. So it's the same equation, just in vertex form. So just to show you, so this is the original equation is x squared plus 4x minus 9. And as you see, I did graph the vertex, that is where it is, negative 2, negative 13. And I'm going to click on my other graph, as you see, red to green. So this is the same function in vertex form, x plus 2 squared minus 13. Right, so we said the vertex was -2, -13. We said that this could also be rewritten as x plus 2 squared minus 13. So we want to determine whether we have a maximum or a minimum. So what we're going to look at is what is a, and we said that a is 1. Well, this means a is positive. This also means, let's do it this way, a is 1. A is positive. This means that the graph, the parabola, is going to open up. So we kind of saw what it looked like. The graph is like this, but kind of give you an idea, you know, the graph is doing something like this here, and my vertex would be here. So the next part of this question, a lot of it is just really like B and D are based on what A is. If A is positive, my parabola opens up. Well, that means that this vertex here, as you see, we go from decreasing to increasing, or you can just look at the point. We know that we are going to have a vertex is going to be a minimum. So just as a reminder, we would say that the minimum is the y value, so the minimum is -13. And that is at x equals -2. So the minimum is the y value, the location is that x value. Okay. So once again, range, it's based off of your vertex and what A is. So what range is telling me is that if the lowest value I can have is, remember, range is y values. The lowest value I can have is at -13. That means the range starts at -13, and then there's nothing to cap it off going forward, so it will just keep getting more higher and higher y values. So range is going to be essentially capped at one end by your vertex. And on what interval is the function increasing or decreasing? So when we're talking about increasing or decreasing, this is going to be your x values. So what we're going to be looking for is this point here. So it's decreasing. As far as this is based on, like I said, we got a minimum. Minimums decreasing changes to increasing. So we're decreasing from all points up to, we hit that x value at 2. After 2, we start increasing. Okay. So if you were doing some like more business math or something like that, or even physics, anything like that, sometimes knowing where a function is increasing and decreasing are important things that you want to know, which is why we were bothering with this. We like to know minimum and maximum values so we can minimize something like maximize profit, minimize loss, things like that. We like to know where something's increasing or decreasing because, like, let's say this is making money. I know where I'm losing money, then I know where I'm gaining money. All right, so this example, I want to do it without any graphing. So first thing is, like I said, we need to find that vertex. So we need really just our A and B. But we see here that what A should be is going to be -1 and B is going to be 14. So if we were to do vertex, which we'll do it all over here, we'll make a nice yellow box for it. Probably don't need that whole area. So remember, what we're going to try to figure out is the x coordinate first, which should be at -b to a. So what we have here is a negative 14 over 2, and then 8 is a negative 1. So this is going to be in a negative 14 over negative 2. This is going to be positive 7. Now we need to figure out what y is. Well, y is going to be at f of 7. So we're going to have negative 7 squared plus 14 times 7 minus 47. So negative 49 plus, just make sure I have my numbers correct here when I do this. Okay. So if we subtract everything, we should be just left with a 2. So my vertex is going to be 7, 2. So right here again. All right, so the next part is we want to determine whether this is a minimum or a maximum value. So I'm going to make myself some space over here again to address the next question. So for B, like I said, we're really focused on A. So A, we said, was a negative 1. A is negative. That means the parabola opens down. So like I said, you can kind of give yourself like a quick sketch of what you think's going on here. Vertex has to be somewhere up here. So we're opening down. All right, so now we know it opens down. Like I said, we're not doing a graph, just like a rough sketch to get an idea what's going on. We can see that when the parabola opens down, we are going to have a maximum. So we have a maximum of 2 at x equals 7. Now, once again, the range, because this time it's a maximum, I'm maxing out at that y coordinate of 2. The most I can be is at 2, so my range would look like this. So remember, your range is just your y values, so my maximum y value is here at 2, and then the y's just keep on going forever downwards. So this case, because it's a maximum, this is where I go increasing first, then decreasing afterwards. I'm increasing, starting at negative infinity, I am increasing up until I hit this point. So that means x values. So up to the 7, I'm increasing. Then I start decreasing afterwards. So from x to infinity, or sorry, from 7 to infinity, I should be just decreasing on that interval. And I didn't rewrite this one. So let me just quickly do that. If I was to rewrite the formula for this, we would have, because of that a being negative, it'd be a negative x minus 7 squared plus 2. Just to show you again, we do have the vertexes at 7, 2. As you see, both graphs, both equations are giving you the same graph, so they are graphing the same line. Oops, sorry. Trying to get this in the right spot. So your last couple problems here, 15, same thing, find the vertex, the minimums, maximums, the range, intervals is increasing or decreasing. Then just kind of give me a rough sketch of the graph. So essentially, you know what the vertex is and whether it's opening up or down. So that's what I'm looking for, vertex, opening up, opening down. Like I said, very rough. Same thing with 16. 17, we did something similar when we were talking about minimums and maximums. This time, see if you can solve this problem, but without graphing, and tell me what the maximum value would be. All right, so our equation here was negative 3x squared minus 12x minus 5. So this is my a because it's on the x squared, coefficient of x squared, negative 3. Coefficient on just the x is a negative 12. That's my b. So okay. Sorry, I don't know if I'm trying to do this. So when we're trying to find that vertex, the x coordinate would be the negative b over 2a. So we'd have a negative, let's put it this way, sorry, negative out front. B is a negative 12. And then we get 2 times a, which is negative 3. So we end up with, if you want to, this negative and this negative would cancel, and you're just left with a positive 12 over negative 6. So I have a negative 2. Now, if I want my y, that's just f of negative 2. Oops, there we go. So that would be negative 3, negative 2 squared minus 12 times negative 2 minus 5. Negative 3 times a positive 4, and this would be plus 24 minus 5. So we have a negative 12 plus 24 minus 5. So that should be a minus 12. Math here. Negative 12 plus 24 minus 5. Oops, 7, sorry. I don't know how I miscounted that. So my vertex would be at negative 2, positive 7. So the other way to rewrite this is, remember, a is the same a, so you would keep a negative 3 out front. X minus h is negative 2, so it would be plus 2 squared, and then the k. Let me write the vertex form again. That'd be my a. This is my h, this is my k. So if I was to rewrite this, like I said, negative 3 for the a, x, we're minusing a negative 2, so plus 2 squared. And then my k is the 7. All right, so we're going to determine whether it's a maximum or minimum value. Well, a equals negative 3. It's negative. If it's negative, that means we open down. If we're opening down, that means that we're going to have a maximum. So my range, like I said, where I max out is at 7 now. Oh, let me put this down. So we have a maximum of 7 at x equals negative 2. The range is going to be, I max out at that 7. So I'm pretty much everything from negative infinity up to that 7, and then that's where I have to stop. Remember, range is just y values. Increasing, decreasing intervals are your x values. So if I have a maximum, that means that starting in negative infinity, I'm increasing up until I hit that negative 2. Then after that, I'm decreasing. So when x passes -2, from -2 to infinity, I'm decreasing. So I have to make my rough sketch. My x -2, 7, that's my vertex. And like I said, we know that's probably a little bigger than I needed. And then we're opening down. Like I said, this is a really rough sketch because we haven't taken into account what the -3 is doing. Other points that we want to look for in the future are going to be x-intercepts and things like that. We could use some other points. Like I said, this is a really rough sketch. That's essentially what our graph is kind of going to look like. So as we see, we're looking at the range. I start from -infinity, and then when I hit 7, I max out. I'm increasing as x from -infinity up to that -2, and then after that, I'm decreasing. All right, so if I remember correctly, this one's a little messy. So we got our function here. We know that a is going to be the coefficient of x squared, so it's 2. B is the coefficient of x, so -7. So when I'm looking for my vertex, the x-coordinate is going to be -b/2a. So in this case, a negative -7 on top over 2 times 2. Negatives cancel out, but I'm just going to be left with 7/4. So that's part of my vertex is going to be a positive 7/4. You can have fractions as vertexes. Okay. Now we need to find that y-coordinate, which we know should be f of 7/4. So we're going to have 2 times 7/4 squared minus 7/4 plus 1. So we got 2 times 49/16 after we do the square minus 49/4 plus 1. That's going to be this 2 and that 16. Just think of that as 2/1. That's canceling, so I'm really have a 49/8 minus 49/4 plus 1. Same denominator on everything. I thought I wrote something wrong there for a second. So if I double the 49 and the 4, I end up with a 98/8, and then 1 can just be 8/8. So if I just add my numerators, I got 49 minus 49 minus 98 plus 8. So that's -41/8. All right. So I actually just scrapped this to make sure that it was right. And yes, that is the vertex. So we want to determine, like I said, you can't get fractional vertexes, that's fine. We want to determine whether this is a maximum or minimum value. Once again, a is 2, it's positive, means we open up, which means we're going to have a minimum. So we're going to have a minimum, or minimum of, sorry, a minimum of -41/8 at the point x equals 7/4. So because we have a minimum, we have, when we're looking at the range, we're saying that the smallest value I can have would be that -41/8, because it's all y values. But then after that, I'd keep going up for infinity. Because it's a minimum, it means we're decreasing first. So we go from decreasing to increasing. So we start decreasing from -infinity up till we hit that x value as 7/4. Then after that, we're increasing. So if we do a rough sketch, just a second here. So this point here is 1.75. See what I really needed. This point is a negative 5.125. Just to kind of give you an idea about where this will be. So roughly, roughly here should be that vertex. And like I said, we should be opening up. So it's going to look kind of like that. And just the very last thing to do again, just for practice. If I was to rewrite this equation here in vertex form, like I said, H, K, we know A, so we would have 2x minus 7/4 squared minus 41/8. Okay, so this question, we took a little chance to try to do this. A stonemason has enough stone to enclose a rectangular patio with a 40-foot wall of stone, or sorry, 60-foot wall of stone. If the house forms one side of the rectangle, what is the maximum area that the mason can enclose? So this is my house here that's taking up this one side. So the only sides I actually need to put stone around are these three. So these two are opposite each other, should be the same size. So I'm just going to say they're X and that's Y. So it's kind of like having W's and then L. So one of the things I know is that X plus Y has to equal 60 because this is the length of each side and I want 60 stone or 60 feet of stone. So I can write that as 2x plus y equals 60. So what we're trying to do is we're trying to enclose a maximum area. So area would just have to be the x times y, like length times width. So what we're going to do is I'm going to solve this for y to solve for a variable. So we get 60 minus 2x. Well, I can put that in here, and then I just have a is x times 60 minus 2x. So now I'm in just terms of x. Anytime you're trying to solve an equation and you have two different equations, what we're trying to do is just solve for one variable. All right, so area is just going to be 60x minus 2x squared, or if you want, you can write that as minus 2x squared plus 60x. Let's get rid of this part up here for a minute. So we have an equation. So you can treat this as, say, this is just fx, if it's area. We got fx is equal to negative 2x squared plus 60x, and I want to find a maximum. I want to find that maximum area, so I'm looking for the maximum of this equation because this is my area equation. So what I need to do to find a maximum, well, that means find vertex. So we know that according to this, my A is -2, my B is 60. We don't have a C, that's fine. So if we're trying to find the x coordinate of my vertex, the x coordinate is going to be the negative b over 2a. So in this case, it's going to be a negative 60 over 2 times -2. So negative 60 over -4, that will be a positive 15. So what I know is that if I'm maximizing this area, x would have to be 15. But we want to know what is the maximum area as well. So to find that y portion, means that I would have to figure out what f of 15 is. So that'd be negative 2 times 15 squared plus 60 times 15. Calculator out, help me through this a little quicker. So this is 225. What I really need is 60 times 15. I knew that was wrong. This will be 900. We keep on going. That is a negative 450 plus 900. So the maximum area is going to be 450. We're measuring in feet, squared feet. So then once again, if we go back to my dimensions, the maximum area we said is 450 square feet. Then we want to know what are the dimensions. Well, that goes back here. We know that the dimensions are x would have to be 15. So what would y have to be? Well, very slow for y down here. We said 2 would have to be 15 because that's what gave us my maximum area. So we should be left with a 30 here. So my maximum area would be, I would have to have like a width of 15 and a length of 30 feet.